Is it recording? Yep. Well, good. I can see it appear from down here with the cool hat. Check. Yep. Hey there, peeps. We're in Familiar Digs. Check out where we are. All right. I'd like to introduce you to Phinneas, the flying, pooping pig, to help me with this next concept in physics. This pig has a special talent, and you thought it was flying. It's not only flying. Okay, of course he could fly. There's no doubt about that. But he has this really keen ability to create poops once per second, exactly once per second. See, well, that was not once per second, but when he concentrates, he can drop poops once per second. So he's a very, very talented pig. And he's going to help us look at motion patterns. So the frequency in this case is known as 1 hertz, or 1 event per second. In this case, 1 poop per second. And in case number 1, Phinneas is going to be moving at constant velocity. So I got these tracks over here that will show us the intervals in this case. They are spaced out evenly. And so at 1 hertz, he's going to be trying to poop at each of these every second that goes by. He'll go 1 unit of distance. Okay. Now we can imagine that they're to scale, but here we go. I've got a little table here to at least track his first 6 poops. All right. We have time equals 0, 1, 2, 3, 4, 5, 6. And the velocity over here is going to be the same, so we got to choose that velocity. Let's say that the scale here is in meters, okay? So each of these blocks represents 1 meter. And let's say he moves at a constant velocity. Keep it simple, 1 meter per second throughout. Okay? So the constant velocity is equal to 1 meter per second. Okay? So what we have over here in this table as we fill it out simply is that velocity is constant, so it's always 1, 1, 1. The average velocity would be 1 because the average of the same, a constant is the same. It's 1, 1, 1, 1, 1, 1. So between 0 and 1 seconds, he's moving at 1 meter per second. Every second that goes by, he goes 1 meter, 1 meter, 1 meter, 1 meter. This is really easy when it's constant velocity. Now let's look at the total distance. Okay? From 0 to 1 seconds, he'll travel 1 meter. That's the interval. And what is his location going to be after the first? That's from 0 seconds. Actually, this would be, well, 0. Now it's 1, okay, after the first second. After the second second, 2 meters. After the third second, he'll be going 3 meters, 4 meters, 5 meters, 6 meters, and so on and so forth. So if we were to track that motion, every second that goes by, he makes a poop. And like this. So 1, 2, 3, 4, 5, 6, and so on and so forth. I only said we're going to do the first 6. Okay, what about a situation where now Phinneas has the ability to change his speed? What would that look like here on the table? What would that look like here in the patterns of poops? Well, let's try to figure that situation out. Phinneas, now instead of going at 1 meter per second, every second that goes by, he increases his velocity by 1 meter per second. So let's see if we could characterize that as case number 2. All right, so he increases velocity 1 meter per second every second. One meter per second every second he increases. So our values change, and in fact, when he keeps producing his gems, his poops, every second that goes by, we'll see that we can actually detect that in the pattern that he leaves behind. It'll look different than this. It won't be even, all right? It won't be equal increments. Time, seconds, 1, 0, 1, 2, 3, 4, 5, 6. Okay, now we start off at 0 meters per second. I'll hold off on the average for a moment. The next second that he goes by, his velocity increases by 1 meter per second. So over here, his velocity is also at 1 meter per second. He increases that by another 1 that goes by because he is increasing velocity 1 meter per second every second. And we have 2 meters per second. He increases it to 3 meters per second, 4 meters per second. He's gaining velocity. He's changing his velocity. We haven't dealt with this before. It's called acceleration, but really it's just a change of velocity over an interval, time interval. And so we'll be able to put this together. Well, now the important thing is to look at the average velocity between the times. So at 0, of course, he starts off at position 0. Okay, but what's the average velocity of 0 and 1? We're assuming now that he's going to steadily increase his velocity 1 meter per second every second. And so the average velocity between 0 and 1, well, the average between any two numbers, you add them together and divide by 2. Simple enough. So the average here of 0 and 1 is 0.5 meters per second. Okay? So if you travel at 0.5 meters per second for 1 second, you have traveled 0.5 meters. Okay? I put the unit here just to be clear, even though it's in the column header. All right. Now, what about between 1 and 2 seconds? The average between 1 and 2 is 1.5. So we have 1.5 meters per second. If you travel 1 second at an average of 1.5 meters a second, you're going to go how far? 1.5 meters. Between 2 and 3 seconds, he travels an average velocity. He's increasing in velocity from 2 meters per second to 3 meters per second, traveling at an average velocity of 2.5 meters per second. From between 3 and 4, it's 3.5. Between 4 and 5, it's 4.5. And between 5 and 6, it's 5.5. And so the intervals of distance, as we can see, is actually increasing as well. As he gains speed, the distance between the poops increases as well. We'll be able to see that as the poop pattern on the track. All right, so the interval is 2.5 meters. The next is 3.5 meters. This is an easy case of 1 meter per second every second. Not everything is this easy, but of course I wanted to choose something that would demonstrate the concept pretty easily. So here we've got 5.5 meters. All right. Now we look at the total. All right. At the end of the first second, the distance traveled is 0.5 meters, and that will be the displacement away as well. How about at the end of second number 2? Well, we travel another 1.5 meters. That would bring us at the location 3 meters, 1.5 plus 0.5. Now, from 3 meters, we are going another 2.5 meters. And so it looks like I didn't add this right. I've got a gallery here saying that I can't add. And Misha isn't around because I'm not at home to help me. Oh my gosh. Hey, what is it, gallery? What is the 0.5 plus 1.5? 2. It's 2. It's 2. See, I'm glad they were here because I would have screwed this up royally. 2 meters. Now 2 and 2.5 is? 4.5. Thank you. 4 plus 4.5 and 3.5. 8 meters. Okay. 12.5 meters and 18 meters. So whereas at constant velocity, Phinneas was only at 6 meters, he's 3 times as far by increasing his velocity once every second. 0.5, 2, 4.5, 8, 12.5, and 18 meters. What does that look like? What would that pattern look like? Well, I'm going to do it with the brown marker, of course. All right, we're going to start here at 0.5. Then we go to 2, like this. From 2, it's 4.5, so it's 3, 4.5, like that. 8 meters, so it's 5, 6, 7, 8. All right, 12.5, so we got 9, 10, 11, 12 and a half, and then 18, so we got 13, 14, 15, 16, 17, 18. I was pretty cool about that track. Okay, so here's the constant velocity, and what we're seeing here is that the gap between the dots, the interval between the dots, is ever increasing. That's a sign of acceleration. So we can actually track not only where he is, but whether or not he changes velocity because of his very consistent talent of pooping once per second. That's acceleration. And so we're going to be doing that in the lab. No, not the pooping, but just the concept of acceleration. We'll be sketching it out, and also actually we're going to be trying to walk and run the pattern of acceleration. That's what it is. All right. Well, here we are, Morad and Phinneas. Out.